Hello, and welcome to today's webinar. My name is Jamie Jimenez, and I'm the Marketing Manager for TFF Systems here at Repligen. Now, today's webinar is all about transitioning from the chaos of running TFF manually to the controlled success that's brought about by switching to an automated TFF system. To do that, Brandon Turgeon, our Associate Director of Product Management, will be talking about the shortcomings of manual TFF, as well as the inadequacies of systems on the market and what you should be looking out for. And from there, Brandon will show us a superior solution in the CrossFlow KR2i. Now, while we are here to talk systems today, I just want to emphasize at the outset that Repligen does so much more than manufacture TFF systems. See, what we do really is innovate, develop, and manufacture fully integrated solutions across both upstream and downstream. And so we offer a variety of products, ranging from hollow fiber and flat sheet cassettes to chromatography systems with resins and pre-packed columns, cell culture perfusion via our XCell ATF and TFDF systems, process analytics tools in our Flow VPX, as well as fluid management solutions to bring it all together. And so, if you don't already, my hope is that when you think Repligen, you think fully integrated solutions for your processing needs. Now, before we hand things off to Brandon, there are just 3 things I want you to keep in mind for today's webinar. Number 1, the webinar is being recorded and will be made available for on-demand viewing at repligen.com. Number 2, we have a live Q&A panel that you can access on the right-hand side of your screen. You can use that panel to submit questions at any time during today's webinar. And finally, as those questions come across, and there are questions that you feel like should be prioritized as part of the Q&A, there is an upvote feature where you have the option to rank questions over others, and we'll be sure to prioritize them during the Q&A. And so with all of that out of the way, let's hand things over to Brandon so he could walk us through today's webinar.
Thanks for the introduction, Jamie, and thank you all for taking time today to discuss a subject very near and dear to me, tangential flow filtration. In our talk today, we will discuss the challenges of manual TFF and bring you from lab chaos to controlled success. I'm Brandon Turgeon, and after 25 years of operating manual TFF systems in both development and production roles, as well as assisting countless industry colleagues discover the benefits of automation, it's easy for me to understand the value of gaining control and ultimate reproducibility of TFF process. I'm hopeful after today that you will agree. So tangential flow filtration, as you likely already know, is a very reliable, widely accepted method to clarify, concentrate, or perform a buffer exchange of bioprocess solutions. The basic concept is to recirculate a solution across a membrane under very specific and repeatable pressure and flow conditions. This enables the membrane surface to remain relatively permeable throughout the process, despite the solution concentration or changes in viscosity encountered. Most importantly, the TFF concept enables a high level of product recovery. Well, if you've operated a TFF system yourself manually, then I think you can agree that executing TFF process can be demanding, requiring continuous monitoring and data acquisition. And you've likely wondered why you aren't using a modernized method of automated TFF system. So the question remains, why are so many TFF systems still operated manually? It's a bit of a loaded question, but let's dig in a little more and explore some of the reasons. Sure, manual TFF is a headache, but that's how you learned it. It's what you're most comfortable with, and it's second nature. And yeah, no one wants to be cooped up in a lab, but I can see everything that's happening in front of me and step in and intervene as needed. I just need to be extra careful and make sure there aren't any mistakes. Or maybe it's the lack of familiarity with the software that's used on automated TFF systems. Having to navigate complicated menus, figure out how to get a run started while having to do lots of other steps manually feels like a lot of extra work. Might as well just run it manually. Or maybe your hesitancy is the time it takes to assemble, align, and sift through all the requirements for a URS. Having to map out process requirements, filter types, volumetric ranges, and all the other parameters could keep somebody occupied for quite a while. And of course, there's always issues with a budget. Some TFF systems on the market could give you sticker shock, especially if the features don't measure up or meet your needs. So what are the actual challenges with operating a TFF system manually? A successful process starts with the equipment and filters that allow for a highly effective, reproducible results. This arrangement you see here requires a user to assume the responsibility of a consistent physical setup each time that doesn't alter the key operating parameters or, even worse, endanger product recovery. This setup also requires an operator collect data manually and does not enable your team to capture or trend some key values required to fully understand your process and contribute to any scale-up efforts in the future. A lack of a feedback loop for basic automation equates to continuous manipulation of manual valves and pump controls that open yourself up to reproducibility issues and, most of all, human error. Let's be honest, execution of this type of process requires a good deal of babysitting and productivity challenges. So what are the impacts to your process of running a system like that? They can be significant. How about the inability to hit your target endpoints and ensure the process is running accordingly? Batch variations in intermittent data can lead to questionable data and add difficulty for any scale-up considerations in the future. Downtime between exchanges of single-use components is a waste of your time and your company's time, and we can never overlook the risk of human error. So the title says it all on this one. Not all systems are created equal. You may be saying, Brandon, I have a system already and it's not versatile enough to use for all my process needs. It's true, there's a lot of benchtop TFF systems with serious shortcomings. The system you purchased may have been a hybrid of single-use and stainless, which left you having to clean components and reassemble single-use after each process. The system still required manual pressure controls, which goes against the purpose of automation in the first place. How about if the data recording was not inclusive and required additional equipment? It would never be able to meet 21 CFR Part 11 compliances if you needed that. At some point, you need to take this process to the next level, and you need a system that will allow you to get there. Many times the system design was geared towards the manufacturer's offerings for filter options and not agnostic to both hollow fiber and flat sheet cassettes. Perhaps there just wasn't enough recipe flexibility and could only operate simple processes due to the lack of equipment capability, which still leaves you operating semi-manually. Many systems are very limited on the volume range of use as well, so you find yourself having to buy 2, 3, 4 systems to get you from development to a pilot or process scale. Well, if any of these impact you, your buyer's remorse may be valid. However, considering what is at stake here, you should not hesitate to find a better solution. And maybe that's why you're here today. So what are the key elements to look for? Simple. A level of automation allows you to maintain critical pressure and flow profiles without manipulation. That's automation. How about a high level of data integrity and monitoring during and after processing? And the software should be friendly to the end user and not complicate the system use. The system should also have the ability to meet 21 CFR Part 11 compliance if needed. How about the TFF system should be designed and capable of a setup that is agnostic to both hollow fiber and flat sheet filters. The flow path itself should provide a high level of reproducibility and built according to your requirements. The system should also include a consideration for scalability. All of these elements that I've spoken of should come together in one cohesive manner as a single solution from the supplier. And if that's not where you are right now, then let me tell you about Repligen. And allow me to introduce you to the CrossFlow KI2i benchtop TFF system. This system is an industry-leading standard for over 15 years and continues to be the highest value TFF system available. Don't be fooled by its simple appearance. The simplicity is an advantage of the CrossFlow systems. We are all familiar with the equipment in this image: scales, pumps, conicals, tubing, and with the addition of other simple equipment such as a back pressure valve and intuitive software, it becomes the level of automation that maintains comfort for the end user with equipment they still understand. So how does it work? Modularity is a key part of this system. The communication and integration through the main pump is possible with an integrated proprietary PCA breadboard. And this is found throughout all CrossFlow systems. The modularity of these components allows you to stay flexible with all your downstream processes. Inside the main pump for all the CrossFlow systems sits a Repligen exclusive microprocessor-based controller that enables bidirectional communication with plug-and-play integration of all the system components. This arrangement plays a crucial role in enabling these small systems to operate with the level of automation previously reserved for only larger skids with a PLC-based system. Integrating other components as needed is as simple as making a connection. That's it. KFCom2 software enables seamless addition and communication across all components. Any other advantages of modularity? How about sharing components between systems? All accessories are easily integrated into each of the 4 available CrossFlow TFF systems. Modularity also allows the end user to configure the components to their requirements in ever increasingly crowded and valuable lab benchtop space. The footprint can be moved, rotated, stacked to be as compact as you need it. So let's talk about the capabilities of this system, where simplicity meets capability. Again, keying in on the simplicity of this system. The process complexity and level of automation varies with the equipment you own or to reach the level of process you need. So what does that mean? Every user has the flexibility to make the system compact, simple, and minimalistic, or expand with more components for more complex process modes. Customer wants to run as simple modes, such as a concentration. They only need 4 core components. They want to level up and run something more complex, like a CDC, a concentration, diafiltration concentration. They just plug and play, add an additional scale and peristaltic auxiliary pump, and they're ready to go. And if you're looking for higher complexity setups and more complicated processes that aren't available from our competitors, like CFC, continuous feed concentration, start with an external volume larger than your retentate vessel, or end your process with conductivity, then it's the same story. Plug and play with 1 or more auxiliary pump and add the conduit sensor unit. That's it. So let's revisit our fears of learning new automation software. I always said that one of the greatest value propositions of the CrossFlow TFF systems is the KFCom2 software. This software controls the entire system, configures recipes, and automates the processes in a matter of minutes through the intuitive KFCom2 software user interface. The software is simple to learn, intuitive, and contains all the process modes you would require to run common or more advanced TFF processes. The software also enables 21 CFR Part 11 compliance with the same package and does not require additional equipment or software add-ons. Some competitive systems, on the other hand, don't even accommodate all the basic TFF applications or lack recipe editing capability within the software, which allows you to determine your endpoint values. And 13 modes of operation is nothing to laugh at. This extensive library of modes allows you to deep dive into all phases of TFF, from flushing membranes to optimizing processes through a flux excursion mode. Let's take a moment to talk about scalability. We introduced you to the KR2i CrossFlow TFF system and told you about its advantages. But now I want to introduce you to the entire platform of CrossFlow benchtop TFF systems. Designed as a single standardized platform and not as a standalone system, the CrossFlow small systems share the same components, software, and controls across the entire family. This allows you to confidently standardize your process, and typical scale-up challenges are removed within the platform. The KR2i and KMPI can bring you from less than 5 milliliters to 500 liters or more within 2 systems. We also have an amazing line of diaphragm pump systems that allow for higher pressure applications, up to 4 bar. These are typically found within flat sheet, high viscosity processes. And while each system family has their advantages for specific filter applications, they are completely agnostic to filter selection due to the configurability advantage we spoke of earlier, and because they also share the same software and auxiliary components. All of these advantages allow for accurate, effortless scale-up. So let's talk about reproducibility. A key part of reproducibility is your flow path and filter options. Repligen is a TFF organization, and not all systems on the market can say that. Repligen hollow fibers and flat sheet cassettes offer a broad range of sizes, surface areas, and membrane chemistries. Each filter line offers linear scalability from process development to commercial manufacturing. Our membranes are low binding with very high flux rates for high process yields. Our single-use cassettes offer unparalleled savings, and our gamma irradiated closed single-use CS line adds additional time savings and value to your process. Did I mention our ProConnex line can customize any flow path to your requirements for tubing, fittings, and even filters for consistent, repeatable processing. We also offer a full line of off-the-shelf flow paths to meet your immediate multi-scale process needs. With technical service teams and application specialists ready to assist, Repligen is the complete end-to-end single-use solution for TFF. So, in summary, if you're tired of the chaos of running TFF manually, but you're also struggling to find a system that ticks all the boxes, then the Repligen CrossFlow KR2i system is a great solution that ensures controlled success within your process. With pre-assembled gamma irradiated tube sets that eliminate the need for autoclaving, to automated TMP pressure and flow controls for hands-off automated TFF operations. Capturing, recording, logging all your data automatically with the KFCON2 software for easy accessing and reporting. All of these elements come together to provide you with a robust TFF solution. Oh, and by the way, do you want to level up? Our CrossFlow RPM systems integrate with the Flow VPX that allows you to measure inline protein concentration measurements in real time. It's a game changer. One last thing I want to mention, in case you needed another reason to modernize your process, I am extremely excited to offer a very rare opportunity in Repligen to acquire a CrossFlow TFF system at a reduced cost. Now, this is not something that Repligen does very often, truly, because the true value of our systems are the technologies and the capability to provide our global customers with an end-to-end solution and extend ourselves as a technology partner with your organization. This offer will only be available on orders placed before December 15th and will extend to many of the critical accessories such as auxiliary pumps, scales, conduit analytics, and even standard flow paths. I want to thank you all for your time and truly hope that you now agree with us as to why our CrossFlow TFF systems are the clear leader in global benchtop TFF processing. and how to get yourself out of the manual chaos. You can contact your local Repligen business partner or contact me directly to discuss Repligen's TFF solutions. Without any further delay, I will hand the control back to my team for a Q&A session. Take it away, Jamie.
All right. Well, thank you, Brandon, for walking us through that. And thank you all for attending. Now we are transitioning to the live Q&A portion of today's webinar. We've got a variety of questions here, and Brandon Turgeon, who's walked us through the presentation, will be addressing your questions here. So, Brandon, you ready to kick things off?
Let's do it.
All right, perfect. Okay, so wow, this question has a lot of upvotes. So we've got a question here from Luke. Can data from this type of system be reliably extrapolated to larger scales / different systems?
Okay. I get this question a lot, honestly. First of all the data is captured in a permanent database without effort. You don't have to choose to select data and capture it. Review it and use it for scale-up considerations later. Just get that out of the way. So within our system family, there is really excellent scalability between the KR2i and the KMPI and the FS15 and the FS500. So that brings you down to several mils up to hundreds of liters. Great scalability there. Now, with any TFF system, when you consider switching to a larger system, may have different valving, different flow paths. You're keeping the core TFF factors consistent, your recirculation flow rates, your membrane path length, and all these key attributes, and including pump type. So is there direct scalability? There's always a need for additional scale-up studies when you go from such a volume of 5 mils to several thousand liters, say, at a larger skid. So there's scalability, the data is valid for sure, but we always recommend additional studies.
Right, excellent. So here, looks like we actually have another question from Luke. So along those lines, any concerns if you're working with shear sensitive molecules like lentivirus? So as it relates to the system, anything I should be worried about if my product's shear sensitive?
Of course. The number one factor is what sort of membrane type you choose, and that should be your key parameter and your key selection criteria for something like lentivirus, which would more than likely be used in a hollow fiber cartridge. The system itself, there is a differentiation between the peristaltic pumps of the KR2i KMPI and the diaphragm-based pumps, whereas the Quattroflow-based systems are believed to have a lower shear impact using the diaphragm pump. So we would, we have customers using either, but there are options if shear sensitivity is a factor.
Mm-hmm. Excellent. So in terms of filter types, here's a question from Richard. Do you have non-single filters?
Yes, absolutely. In flat sheet and hollow fiber, single use is something we specialize in here at Repligen. Of course, we are able to offer single-use filters at a reduced price, whereas some of our competitors just take the same filter and offer it as single-use at the same cost. And we've mastered new techniques that allow us to offer a more robust and well-controlled filter for single use. But we do have them for both hollow fiber and flat sheet. Sorry.
Mm-hmm. Excellent. All right, so here is a question here. Maybe this is someone who's looks like they are a user of manual TFF in their process.
Okay.
So one reason I prefer manual TFF is to stay flexible, not limited to pre-canned recipes. So how does your system maintain flexibility?
Okay, I mean, that's a great question, and it's one of, to be one of the value propositions of our system. Firstly, we do have a really robust quantity of pre-canned recipes, as you call them. And they're recipes that not all of the competitive systems are able to offer, such as continuous feed concentration, even certain flux excursion modes to help process optimization studies. But beyond that, we have a really critical feature within our recipes that you can select to allow changing and manipulation of your retentate flow rate and your pressure profile during process of a recipe. And you can select to lock this or allow it for your operators. And those are the two key TFF parameters, your pressure profile and your flow rate. So that allows you to have the consistency of a recipe, but update your process as needed with the inconsistency of your starting solution. And we also have a manual mode, of course, that you can operate.
Excellent. Okay, so that should alleviate any concerns about limitations or loss of flexibility if I were to embrace a system.
Yeah, indeed.
Uh, yeah. So, question here from Dave. Thanks for the presentation. Oh, thanks for coming, Dave. Looks like a great system. Can you only use Tangentix membranes with the system? How flexible is the system with other suppliers' membranes? Good question.
Yeah, no, the systems are agnostic to whatever type of membrane you want to use. We have variations of filter plate inserts, which allow for single-use cassette use, depending on which competitor cassette you're using. And of course, hollow fibers are easily swapped into the system. We do load the recipe with all of our Repligen hollow fibers and flat sheet membranes baked into the software. And that allows you to select and already know your extra capillary space and all these things that add up in the recipe to result in your best volumetric equations. But the software and the system are completely agnostic to filters.
Mhm. Excellent. All right, so we have a question related to the automation features of the system. So this question is
Okay.
from Liz. You mentioned TMP control. The system also automate permeate flow control.
Yeah, just to be clear, when we talk about automation at all, there's two parameters. There's variable ways to control your pressure profile, whether it's TMP, you can also control it by feed pressure, retentate pressure, permeate pressure, and even a new delta P mode for high viscosity solutions in rare cases. And then the system automation also enables you to control various flow rates, typically your retentate flow rate. But for some applications, you may prefer to control your permeate flow rate, and that's the advantage we have of the modularity with the extra permeate, the extra auxiliary pump that you can place on your permeate and have a permeate flow control. Did that answer that? So yes, we can automate permeate flow control.
Yeah, perfect. So going back to the whole idea of having everything documented, being able to capture my data. So how easy is it to run the pumps and valves manually through the HMI and still retain the records?
Yep, good question. We have plenty of people that choose to operate systems manually. It depends which part of the industry or development you're in, and it just may be more simple for you to operate in a manual mode. So, of course, we do have full access to all the controls in the manual mode, and it's really simple to operate. And anything you run in this software automatically saves your data. There's no effort needed to save your data. So once you're running in manual or a recipe, all your data is automatically saved within this very secure SQL database. It can be monitored live, recipe, or manual mode, and retrieved as needed. But yeah, manual mode is certainly an advantage for many of our users.
Okay, perfect. So question here, what sort of the systems/membrane can separate small molecules 50 to 150 Daltons?
I'm sorry, could you repeat the question, Jamie?
Sure. What sort of the systems, I think the question is, which of the systems/membranes can separate small molecules 50 to 150 Daltons?
Okay, I mean, that's a two-part question, right? And, the part that's relative to the systems, I would say, if you're separating a very small molecule and you're using a very tight membrane, you could possibly see higher pressure profiles. My recommendation would be to, examine the capabilities and the feasibility of using the QuatraFlow-based FS systems. With the membrane selection, I easily refer these questions directly to our FAS scientific team or the product managers for the membrane, cassettes and hollow fibers, and make sure that we work with you to provide the right recommendations.
Perfect. Sounds good. And we're just about out of time. So we'll ask one more question. And for any
Okay.
questions that are remaining, just know that we will be following up via email and we'll be reaching out to provide answers to those questions. Additionally, you can feel free to reach out directly to your Repligen BAM or contact so we can follow up with you as well. Last
Or
question
me.
here, or Brandon. That's right. Last question here. What about mixing?
Boy, you just sneak that one in at the end. So mixing is always a hot topic, especially in an environment of ultra high concentration MABs, for example, where your high concentration, it gets very critical with small volumes to have good mixing. And we've always felt very confident about some of the solutions we provide. And, there's multiple pieces of this, but I'll give you an example. The KR2i system comes standard with 4 sizes of conical retentate reservoirs. Their ported caps allow for the best mixing that we find within there, but it's a convection mixing, and it may not be right for everybody. But they are arranged in a particular manner that allows the buffer to properly mix with the retentate stream and the feed to, feed the system not directly from the bottom and avoid, core mixing. So we have these conicals that we feel very confident about for most applications, and we're a solution company. So we also have an entire ProConnex and fluid management portfolio where we work with vessels and tubing and everything you need. Our FS systems come standard with flat bottom vessels. And the idea is we're selling a high pressure system. There could be a chance that there's a high concentration. We need better mixing. So flat bottom vessels allow you to use stir plates and stir bars with these systems. So I think mixing is a very deep dive. And I was going to say we could do a whole webinar on it, and we just did, right, about a week ago. And it's a really critical parameter, but it's very specific to each process. And I'm confident Repligen has solutions for each of those scenarios. And it's just a matter of reaching out to us as a team to work towards it.
Yeah, that's right. I think that's good. And yeah, it does go back to what we mentioned at the outset that, really Repligen is all around providing fully integrated solutions. So come to us with your unique specific applications and we can custom tailor work with you to come up with some innovative solutions as it relates to mixing or anything within your TFF process. So
Yeah.
with that, I know we're over time. I just want to say thank you again to all who have joined us today for this webinar. Thank you, Brandon, for your presentation, for fielding the questions. And as I've already mentioned, we will be following up via email, so please keep an eye out for that. And any questions that haven't been addressed here, we will be following up, or feel free to reach out to Brandon or your Repligen contact directly. And so thanks again, and we'll catch you in a future webinar. Thank you, Brandon.
Thanks, Jamie. Thank you all.